So let's get started. Hi, my name is Jordan Scott. I'm an account manager here at NetBees, and welcome to today's webinar about what you should know about network speed tests. Also presenting with me is Stefano Gradelli. So for today's agenda, we will be divided into three sections. In the first section, we'll review the correlation between network performance and end user monitoring. Here, we'll cover network metrics that are familiar to you, like round trip time and packet loss. In the second section, we'll review the different types of network speed tests that are available. We'll cover each one of the tests that you'll see listed here, such as Ookla speed tests, NDT, and so on, and highlight things that you should be aware of when planning your network throughput monitoring. In the last section, Stefano will go over a demonstration of the NetBees dashboard showing you how you can run those tests on a Raspberry Pi, Linux host, or virtual machine. With that said, let's move on to the first part. So we all know that network performance does impact the end user experience. Do the end users care about packet loss, round trip time, and throughput? Not really. What end users care mostly about is that websites and cloud applications load fast, that video streaming and voice calls are clear, and that they can download files in the shortest amount of time possible. On the other side, though, for network engineers, they are mostly concerned with network performance metrics, and those metrics can easily be correlated to the end user experience. A study performed by the Stanford Linear Accelerator Center showed a clear correlation between round-trip time and HTTP response time. More specifically, in this graph, you can see that for each data point, the lower bound of an HTTP GET is twice its round-trip time. That's caused by the fact that a minimal TCP transaction involves two round trips. One to establish the connection between the client and the server, the second one to send the HTTP GET request and receive the response. So if you are a network engineer or administrator, you should have a basic understanding of three main metrics: round trip time, packet loss, and throughput, and how these three metrics impact the end user experience. Another key metric is jitter, but today we won't really cover this one in much detail. So, round trip time. This represents the time that it takes for a data packet to go back and forth to a specific destination. This value is tightly correlated to the distance between two hosts plus the delay at each intermediate hop. Delay is the time that it takes for a packet to be processed at intermediate hops between source and destination. Network latency is the time that it takes for a packet to travel across one network link. This value can be approximated with the distance or length of the link divided by 0.6 c, where c corresponds to the speed of light. So for this example, they see the equation to calculate the round trip time is 2 multiplied by the distance between source and destination divided by 0.6 c plus the sum of the delay incurred at each hop. I know this is a lot, so if this is too much for you, let's take a look at some real examples. So in this table, you can see different values of round trip time based on the type of network. As you can see, a local area network, or LAN, has between 1 to 5 milliseconds, where the metropolitan area network is between 3 and 10 milliseconds. So if you consider international links, the round trip time can be 100 or more milliseconds. So I'd say keep that in mind when you're running some troubleshooting ping commands. Now, let's move on to the next network metric, packet loss. Packet loss is a good measure for link quality. Packet loss is calculated as the percentage of packets that are received, malformed, or not received at all by the destination host. When a packet is malformed, it means that somehow along the way, some parts of the packet were not correctly transmitted, causing the TCP checksum at the destination not to match the value calculated at the source. Different story is the case of packets not received at the destination. Along the way between the source and destination, It may happen that intermediate routers discard these packets due to congested queues. This happens when a router is receiving more packets than can actually transmit. When this happens, routers will start discarding these packets. So how does the packet loss affect the end user experience? Simply put, the TCP congestion control and avoidant algorithms rule the throughput that can be achieved between a source and a destination host. So when a packet loss happens in a TCP transfer, the throughput is reduced and stabilized to match the speed that the network can sustain. We'll see more of this in detail in the next slides and the impact of this event. Finally, we can cover throughput. Throughput is the amount of data successfully transferred between a source and a destination. This parameter should not be confused with bandwidth or data rate. Bandwidth, like data rate, is the maximum throughput achievable on the network or link and is generally established by the media and encoding technologies. Throughput is the actual transfer rate achieved between two hosts. Since TCP is the protocol used by the HTTP to browse web pages, as well as to transfer files, so we'll now analyze what network metrics impact the web browsing and download experience. There are three core parameters that affect throughput in a TCP connection: MSS, which is a maximum segment size, round trip time, and packet loss. The Mattis equation shown here states that the maximum throughput achieved by a TCP connection can be calculated by dividing the maximum segment size by round trip time and multiplying the result by 1 over the root square of packet loss, where P obviously is the packet loss. As you can see, packet loss and latency are pretty important metrics to be aware of. So now let's talk about bandwidth delay product. Probably you are aware that TCP is a connection-oriented protocol. That is, every packet sent by the sender must be acknowledged by the receiver, differently from UDP that doesn't require this acknowledgement. TCP will assure that all packets are successfully received by the destination host. Should the source not receive an acknowledgement for one packet within a certain amount of time, it will transmit the packet until it's successfully received and acknowledged by the receiver. The amount of data sent by the source on the circuit but not yet acknowledged is called bandwidth delay product. This value can be easily calculated by multiplying the data rate of a link by its round trip time. So to summarize, to achieve maximum bandwidth on a link, the TCP window size should correspond to the bandwidth delay product. Most network connections don't require any special tuning of the TCP protocol, though. However, in a case for long fat networks where the BDP is larger than 12,500 bytes, some tuning may be required, like the support for TCP window scale option. So now on this slide, you can see a real example of the impact of packet loss and round trip time on TCP throughput. This chart was created by the staff of ESNet when they're dealing with a dirty optic on one of the routers. The optic was causing 0.0046% of packet loss. That corresponds to one packet every 220,000 packets. A very little number, yet if you follow the trend of the blue, red, and green dotted line, you can see how the throughput quickly decreases as the round trip time value increases. Now on the other side, the purple line represents the throughput with no packet loss. This value slowly decreases as the round trip time increases. So it's pretty clear that packet loss is an issue that should be quickly detected and corrected, as it could have tremendous impact on the network performance, thus your end users are having a bad time. So why network speed tests? Well, we've done a little bit of the heavy lifting with some of the theories. So, why is this important? Network speed tests are super useful tests that every network engineer should run on the network. By periodically testing download and upload throughput, the network engineer can detect network performance issues that may impact the end users as soon as they occur. So if you want to detect problems before the users do, we highly encourage you to run speed tests on your most important links. Another great reason to run speed tests is to build your own throughput baseline if needed and enforce service level agreements with ISPs. At NetBees, we have helped numerous customers do this. So now let's review the four network speed tests that are pretty popular within network engineering community. There's the Ookla speed test, NDT, Netflix's fast.com, and last but not least, there's the iPerf. So the Ookla speed test, it's a browser-based internet throughput test that can be easily run from any client going to the URL speedtest.net. This test reports download, upload speed, and round-trip time to the speed test server on the internet. Thanks to its simplicity, this test is very popular, and typically ISPs request to run it when home subscribers complain of their internet connection is slow. It happens a lot. The Ookla speed test network includes more than 7,600 global servers, mostly hosted by third parties such as enterprises, ISPs, and public organizations. For this reason, when a user runs a speed test, the algorithm first checks for the server with the lowest round trip time, then starts the test. The speed test client can also be run from the command line, and that makes it easier for network engineers to automate this test via Linux. You can find the links to the open source projects on the bottom part of this slide. Next, NDT. It's a test that's very similar to the Ookla speed test, but with a slight difference. It's not developed by a private company, but by the MLab. MLab is a consortium of public and private organizations that aim to offer an open and verifiable measurement of global network performance. NDT reports download and upload speeds to an NDT server, plus information about the network path between the client and the server. So for example, NDT can tell you if the packet size is preserved along the route, if there's a firewall or NAT device in between, or what the speed of the slowest link looks like. This is very useful information to network engineers that need more visibility on internet links. The one drawback of NDT is that they have a lower number of available servers when compared to Ookla. At the moment, we count about 139 servers on the MLab's website. Perhaps there are more servers out there, but one thing worth mentioning is that this test is integrated with Google. So if you simply search speed test in Google, you can run an NDT test right from the top of the results page. You should give it a try after this webinar, of course. So, and our third speed test is fast.com, which is actually provided by Netflix, the online streaming service. The concept behind fast.com test is simplicity, because Netflix users are mostly downloading content when streaming movies. This test primarily reports them in megabits per second. However, if you click on the Show More Info button, you'll find more than just the download speed. The test details section also includes upload speed as well as latency loaded and unloaded. Well, what are loaded and unloaded latency, you may ask? Well, loaded latency is when the source is sending at a higher throughput than the connection can sustain. Unloaded latency is the opposite. So if the loaded latency is much higher than the unloaded one, that means that the router is affected by a buffer float. Buffer float is a phenomenon that occurs when routers are buffering more traffic than they should instead of dropping packets. So as we learned in the previous slides, packet loss enables the TCP connection avoidance and control algorithms to adjust the throughput between source and destination to reflect the actual capacity or speed of the network. If too many packets are queued instead of being dropped, the source overestimates the speed available on the network, causing throughput to go up and down without adjusting. This problem causes bad performance for the end user or some human pain. Fortunately, not all the routers are affected by this, so some of the routers that are affected by this release the patch that you can correct this behavior. So if this does apply to you, I'd check out that patch. Now for our last speed test, let's introduce iPerf. In our experience, we find iPerf not to be the first choice to run tests to external third-party servers on the internet. The best use case for iPerf is where both the client and the server are owned and managed, and where the network engineer wants to test throughput between two endpoints. So if you want to test network speed between your offices, iPerf is the best choice. iPerf supports TCP, UDP, multicast, and the SCTP protocol. iPerf allows you to tune many of your TCP/UDP throughput tests, such as destination port, DSCP value, packet timing, packet size, MSS size, etc. So for this reason, iPerf is well known in the network engineering community and amply used. So this concludes the second part of our webinar. Stefano will now show you a demonstration of the NetBeast dashboard and how you can run these network speed tests on a Raspberry Pi or any other Linux-based host. I appreciate you sticking around with me. So Stefano, the audience is all yours.
Thank you, Jordan, and hi everybody. Hope you are enjoying the webinar so far. So to show you this third part of the webinar, I'll go through the NetBeast dashboard to see what it's like. If you're not familiar with NetBeast, NetBeast is a distributed network monitoring solution that relies on remote agents that can be based on Linux as well as a Raspberry Pis. You deploy these agents all around your enterprise network, and then from the central dashboard you can manage the agents, configure tests, and then the test results are sent in real time to the dashboard for processing, alerting, and as well as visualization. So I'm sharing now the screen with the NetBeast dashboard. Here you go. You can see I'm not going to go in detail into each element of the dashboard, but the most important part probably is the Agents tab. You can see here that we have a certain number of agents managed by this dashboard, and you can see the different kinds of agent that it supports. Fast Ethernets are based on Raspberry Pi. External can be cloud agents to monitor from the internet perspective. Then there are virtual agents and Wi-Fi agents. We also have gig agents, and then you can also load NetBeast on a 10 gig or 100 gig server if you want to run more throughput or speed tests on your network. So in regards to the network speed test, as Jordan was saying, NetBeast supports all the 4 tests that were listed in the slide deck. And we have 2 ways to run this test on via the NetBeast dashboard. We have ad hoc testing that allows you to run tests in real time ad hoc, for example, when it's needed for troubleshooting purposes. Think, for example, like a user at a remote site where you have a Raspberry Pi deployed are complaining about speed test. So the Raspberry Pi to simulate an end user in the end throughput is just good enough to do that. So you can run a speed test straight from your dashboard. So that's an ad hoc test, run ad hoc. And the second way is through a scheduled test. Schedule tests are very useful because allow you to run on a specific time of the day or the week or the month with like a cron job, the test on your network, get the results, save the results, and then you basically build a performance baseline on your network. You can also see if the speed is decreasing, and that probably shows that you might have packet loss or other issues that Jordan just showed during the slide. So for instance, here we have an iPerf test between 2 agents and the output of the UDP iPerf test. You see the bandwidth, the jitter, and the packet loss. So it's a pretty good throughput. This test was specifically set to 5 megabit per second because it's a low speed circuit. But we also have a throughput here in TCP, where in TCP with the iPerf version 2, the source and the destination will try to send as much throughput as they can, as the network and the link supports. So here you can see in average is about 60 to 70 megabit per second. Moving next in the speed test tab, you see that Under speed test, we have the UCLA, the NDT, and the fast.com type of test. So I select here this internet bandwidth schedule test that runs every hour at the 0, 25th, and 35th minute of the hour periodically. You can see this is the average bandwidth from all your sites. And then if you click on the details for each individual test run, you can see the bandwidth for each individual site. Then you can also drill down at that site and see what is the trend or the speed at that specific site. So let me show you now how to run a speed test maybe on NetBeans. We can start maybe with an iPerf test. As Jordan was saying, iPerf support many different options. In this case, I pick the source and the destination agent. I'll do a TCP throughput test. I use version 2, but we also support version 3, and then different ports. I'll leave the same default parameters that come out of the box through the command line. As you can see, also you can set the SCP value. So now I click run, and the dashboard is sending the message to the agents to start the speed test in real time. And then the results will be sent here. So as you can see here, the exchange has started, and in real time for 10 seconds, I'll see the throughput results between the two Pittsburgh agents. This test will run for 10 seconds and then exit. There you go. The other type of speed tests are under the speed test tab. As you can see, we support the 3 version or 3 types. In the UCLA, you put the source agent. Again, I'll take the Pittsburgh one, and you can choose to do a secure or not secure speed test. If you leave the UCLA server ID, it's gonna pick, following the algorithm, the closest server with lower round trip time. So most of the times you wanna do that. Or if you have a specific UCLA server ID, you can enter the ID there. Again, the server ID you'll find on our slide deck, but also searching on Google UCLA speed test server list. So then you do the lookup of the server ID and then you insert it there. So now, same for iPerf, the test is pushed to the agent is running the test, and then it will send the output. In this case, different from iPerf, you just have to wait for the test to exit. So there is not like the real-time scrolling as in iPerf. Then I moved to the NDT version of the speed test. Here I added the server FQDN. We also added here a link to the NDT list of servers on the map. You can see here there are the servers that you can use to run your NDT test. I basically got this server URL from that list, and then I click run, and then the agent will run the NDT test. In this case, we're based in Pittsburgh, Pennsylvania, so I selected the YAD02 server, which is located in Washington or in the DC area. Same deal for UCLA. It will run the test and then send the results to the console. And we can at least compare the different performance between UCLA and NDT. I suspect that UCLA will report a better result than the NDT, because UCLA has a closer server here in Pittsburgh, while in fact the NDT has another one. And lastly, the fast.com. Fast.com, as Jordan was saying, is a very simple test. You really don't have to set anything. Just select fast.com, click run, and you get as output your download speed to the closest Netflix CDN server in the end. So again, in this version, we only report the download speed, which is the simple option of the fast.com server. But if you want to check it out, here is actually the download speed, which is really in line with the one found by UCLA, and kind of in line with the NDT download, while the upload is not really in line with UCLA. But it's nice to see that overall they kind of return the same results. With this, I'm done with the demonstration for this webinar. What we can do now is see if we have any Q&A in our list and take your question and answer. Okay. Okay, so we have the first question by Nicholas, who's asking, what about nperf.com? So we didn't include, that's a great question, and perf.com is another speed test option that you can run. We haven't included this in NetBeans nor cover in this webinar, just for, we basically pick and selected what we found in our, the tests that mostly get requested by our customer, but definitely that's another option for network speed test available. Another question is, how much bandwidth can you push with iPerf? That's a great question, and it really depends from the underlying hardware that you're using to run the iPerf. For example, we just came back actually from the Supercomputing 18 conference, and we work with the SciNet team there. They, at the Supercomputing conference, they built the fastest temporary network. They were pushing 4 terabit per second, just to give you some numbers. And what I found there is that there are 10 gig and also 100 gig platform that you can use to run iPerf on top. And the results have been pretty good. So the bottom line really, as long as the Linux TCP stack supports and you have the hardware available, you can really push as much throughput as the hardware can support. So again, there is a probe also 1 gig around like $800, I think. And for a 100 gig card, the price has dropped as low as $1,200. So pretty good. So the beauty, again, you can use iPerf to run also high throughput tests. All right, the last question is there a way to share information on the dashboard with the end user? So I guess this is something really related to NetBeans, but yes, there is a way to share the information on the dashboard with the end user. What I can show you actually is that's what we call the NetBeans public dashboard, which is a dashboard that is written in PHP and that we build ourselves using our public API. This template really shows all the data collected from the agents in terms of speed test, but also network monitoring data. So let me show you if I found the share button, which I'm having problems to find the share button. Okay, sorry, thank you. All right. Okay, so if you see here, this is the public NetBeans dashboard that we build. Is available on GitHub, actually. Here is the URL, or you can search on Google. There you go. But the public share dashboard show you, all the latest speed tests run by your agent. So you can see here the values are pretty low. And then if you click on a specific agent, you can see in more details the results of the speed test for the time range that you selected. 1 day, 1 week, 1 month, and so on. So yeah, there is a way in NetBeans to share with a public API or with other integration the data collected from your speed test. All right, I think, let me see, we might have another question. No, I think everything was answered. With that, I want to thank you all for your time, for attending this webinar.